Okay, so we're going to be talking about tangent lines, and we're going to get into the word called derivatives. And you've probably heard the word derivatives. You're finally going to figure out what a derivative is, what it means, and we're going to be using derivatives the rest of the year. It is one of the most important things to learn about calculus. Knowing what it is and how it's used is really, really important. And so this particular unit is trying to sort of figure out what a derivative is and how you use it. And in the next unit, we'll actually do the algebra with it, and we'll say, okay, here's the derivative of this function, and here's the derivative of that one. Right now, we're just sort of doing the process and kind of understanding what a derivative is. Before we talk about a derivative, we need to talk about tangent lines. You probably remember from other classes that, especially with a circle, that you could draw a tangent line. Like if I wanted to draw a tangent line at this point right here, I would draw this line that goes through the point that sort of looks like the graph, maybe like that right there. That would be a tangent line. And that's true. You heard that a tangent line is a line that goes through the graph that only touches the graph at one point. It's not exactly true. If I wanted the tangent line at this point right here, this is not a tangent line. It does go through the graph at one point, but it doesn't look like the graph. With tangent lines, they look like the graph at that point. So if I were going to draw the tangent line, it would be sort of like that right there, because it sort of matches what's going on around that graph. Like right around there, it kind of looks the same. So on a parabola, if I wanted to draw the tangent line at this point right here, or we'll just draw some at different places, that would be a tangent line. It could be flat. It could kind of just sort of touch that point, but not really go through it. And that's really what happens most of the time. Let me redo that one. It's hard to draw here. There we go. That right there would be a tangent line. It's sort of just touching the graph. It's not really going through it. It's just sort of touching it. That would be another one. Notice that the slope of the tangent line has to do with sort of the shape of the graph. That's really important. Another thing to know about tangent lines, if I wanted to draw the tangent line through this red dot on this cosine curve, then it's actually going to touch more than one point, and that's okay. We used to think that tangent lines only touched at one point, or sort of just kind of grazed it at one point, but in this case, it's going through it at 2 points, and that's okay. It actually could even touch it at other points where it's not tangent. So let me show you one more example about that. Well, there we go. Let's say I wanted to draw the tangent line at this point right here. It still would be flat because right there it's around 0. The slope would be. So that's the tangent line at that point. Notice it is touching at another point and it's not tangent there. That's okay too. So a tangent line can touch as many points as it wants to, but a tangent line at a point, it sort of looks like the graph at that point. Now, you're not able to draw tangent lines on every kind of graph, so let me show you a couple of examples where you can't draw a tangent line. Okay, on the first one, let's say I wanted to draw the tangent line at this value, which is x equals 2. Well, maybe there's a point up here even. We can just put a point there, it doesn't matter. So the tangent line has to go through that point, and it has to look like the graph. And it has to sort of touch or graze the graph. Well, I could kind of maybe draw something up here, and it does kind of look like the graph, but it's not even at the same location. If I wanted to do it and there wasn't another point, well, around it, that could be the tangent line, but because it doesn't actually go through anything, it has to go through the point at that x value, then it can't look like it. So this one has no tangent line at 2. So this one, the next one, let's say I wanted to draw the tangent line at x equals 0. Well, if there were a point there, then I would try to match the graph and kind of touch that point. But even though there's not a point, there's no way that the only line I can think of would be this line right here. And it sort of would match it as this graph gets closer to infinity and as this graph gets closer to infinity. But the problem is that the slope of that graph is undefined, and because the slope of that graph is undefined, we don't have a tangent line there. Our tangent lines that we have always have a slope of 0 or a number, positive or negative. But the fact that that slope is undefined makes it not have a tangent line. And then this last one, there is a tangent line over here on the left or the right of the curve. The tangent line is actually itself. So that's the tangent line and that's the tangent line. So it is itself, and that's okay. But if I wanted to draw the tangent line here at the cusp where the sharp point is, the only possible thing I could draw maybe would be that flat line, but that doesn't look like the graph at that point. It's got to have a property called local linearity. Local linearity means that when you draw a tangent line, that it looks like a line around that point. And at that point right there, it does not look like, that graph does not look like a line. So when I draw that tangent line, it's not matching the graph, and it doesn't have the property of local linearity. Now, understanding what a tangent line is really important, because that's going to get us into what the definition of a derivative is. So here we have a graph where y equals f of x, and we have 2 points on the graph, x and x plus h. You can sort of think of h as the distance from x to x plus h, because if you subtract that, that's how much it goes up. So if I wanted the y values of those points, I don't know exactly what it would be, but if f of x is the function, then to figure out the y value at x and the y value at x plus h, then I plug those things into that. So this y value up here is going to be f of x plus h in parentheses. And this value here is going to be f of x. Well, we're talking about these tangent lines. And so what we're trying to do is we're going to try to figure out the slope of the tangent line at the x value. I want to know what that slope is. And I could sort of estimate it. I know it's positive because the graph is going up. It's a positive slope. I don't really know what it is, though, and without a grid, it's harder to figure out. So we're going to figure out a way to do it. So what we're going to do first is we're going to draw a line between x and x plus h. The yellow line is called the secant line. A secant line is a line connecting 2 points on the graph. So, well, that slope is positive, so I guess it's close to what the slope would be, but it's not really the same. It doesn't really match. Well, what if I moved x plus h closer to x? If I moved it here, and if instead I draw the secant line between x and x plus h, except x plus h is a little closer to x. Well, if I find the slope of that line, that green line, I'm getting closer to what that blue line is. Still not exactly the same. It's still positive, but I'm getting closer. Well, we'll do one more line. Let's say that we move it even closer. Well, we're getting really close. The closer we get to it, the closer we get to finding the slope that we want. Let's just go back for a second and find the slope of the yellow line. Remember that slope is rise over run. You take the y's and you subtract them. You take the x's and subtract them. Here's our y's. F of x plus h minus f of x. And then you divide it by the x's. So that's x plus h minus x. This looks familiar. F of x plus h minus f of x all over h. That is the slope of the yellow line, which is the secant line. Now what I really want though is the slope of the tangent line at x. Notice as I moved closer and closer and closer to x that the slope was getting closer and closer to the slope that I was really wanting. Well, as I move closer, what's happening is h is getting smaller. The distance between x and x plus h is getting smaller, so h is getting smaller. So if I do the limit as h approaches 0, meaning let h get as small as possible, even as close to 0. If I could find the limit of the slope of the secant line, then I could figure out what the slope of the tangent line would be. So this formula tells me the slope of tangent line. You've already used this formula quite a bit. Now we're just now understanding what it actually means, and it represents the slope of the tangent line. Some other symbols it represents is f prime of x. That's just a symbol. If I say find f prime of x, I'm asking you to find the slope of the tangent line. It is the derivative. If I say find the derivative of this equation, this is the formula you're going to use. Okay, so a derivative is basically the slope of a tangent line. So now let's talk about how we actually use it. Let's say that I have f of x equals x squared plus 1. And first of all, I want to find the slope of the secant line between 1 and 3, between x equals 1 and x equals 3. So the slope of the secant line is just the slope between any 2 points of the graph. So I need to figure out what f of 3 is and what f of 1 is. Plug in your 3, plug in your 1. So now if I want to find the slope of the secant line, I take the y values, subtract, and then divide it by the x values and subtract. Make sure that since this was f of 3 and 10 was first, that on the bottom I have to start with 3. So my slope is 8 over 2, which is 4. So if I draw x squared plus 1, and I find the slope between 1 and 3, if I draw a line there, then I'm saying that the slope is approximately 4. Okay, so that's the A part. The B part is to find the slope of the tangent line at x equals 2, and then even some other values in a minute that we'll look at. Alright, in order to do that, then we have to use that formula, the limit as h approaches 0, f of x plus h minus f of x all over h. And our formula again was f of x equals x squared plus 1. So if I'm going to use this formula, I'm going to figure out what f of x plus h is, which means I'm going to plug that in. I'll go ahead and work it out. X squared plus, remember the outside and the inside makes 2xh. So now to use the formula, we would have the limit as h approaches 0 of f of x plus h minus f of x all over h. Alright, so the x squareds will go away. That's a minus, so it's x squared minus x squared. 1 minus 1, that will go away. So I can factor out a h on top. I'm left with 2x plus h. Plug your 0 in for h, so we get 2x. Alright, 2x represents the formula for the derivative. This represents f prime of x. So if I want to know the slope at x equals 2, then I'm going to take what I got for the formula and multiply by 2. If I wanted to know the slope at -1, I would take my formula 2x, plug in -1. And that makes sense if you think about the graph, because x squared plus 1 looks kind of like that. If I go to 2 and I draw a line, the slope is approximately 4. If I go to -1 and I draw a line, the slope is approximately -1. And so that is the way that you find that. This f prime of x is like your formula. And then if you want to find the slope at any point on that, you just plug those values in for x to figure out the slope at those places. Now, the C part, which is the last part of what we'll be doing, is find the actual tangent line. Figure out what the equation is. Now, we found in B that 4 was the slope. So at x equals 2, the slope is 4. Now, we know that x equals 2. When we write the equation of a tangent line, we're going to have y equals mx plus b. We're going to fill in y, we're going to fill in m, we're going to fill in x, and then we're going to solve for b. Now, you can use the point slope formula, and if you like that formula better, go for it. I'm usually going to use this one, but the other one is okay. What we need to do is we need to figure out the y, and we do that by using the f of x formula that we already have. F of x equals x squared plus 1. If I plug in the x into x in f of x squared plus 1, I get 2 squared plus 1, which is 5. So that's my y value. So now I plug in everything I know. 5 equals 4 times 2 plus b. Subtract 8. So the equation of my tangent line would be y equals 4x minus 3. So on these problems that we're going to be looking on, you're going to be figuring out what the slope of the secant line is, what the slope of the tangent line is, and what the equation of the tangent line is. That's pretty much what you're going to be doing. Now, one quick example of that, let's say you have f of x equals 4x. Now, I could do the whole process, but I don't want to on this one because 4x is just a line. If I pick any value or point on that line, what is the tangent line? Well, it's the same. So the tangent line at any point, no matter which point I choose, is y equals 4x. If I wanted to know the derivative at 2, that just means the slope at 2. Well, the slope at 2 is the slope of the line, which is just 4. If I wanted to know the slope at 0, it's still 4. The slope is always 4 at every point. If I wanted to know the slope between 1 and 3, well, maybe there's 1 and here's 3. The slope between there, still 4. If you start off with a line, you don't have to do any work. You just have to realize, oh, we're talking about a line. So the slope of the line is 4, and the tangent line is itself. Alright, I'm going to do one more example similar to number 1 just so that you can see the process one more time. We're going to have f of x equals 4 over x. And I want to find the slope of the secant line between 1 and 4. So I'm going to plug in 1. It'll be 4 over 1. We'll plug in 4. 4 over 4, which is 1. So then I just find the slopes. I do the y's and subtract them over the x's and subtract them. And then I get 3 over negative 3, which is negative 1. Now, if I graphed 4 over x, you want to get a graph that looks like this. And 1 and 3 or 1 and 4 are over here. If I connected those with a line, I would get a negative slope, so that makes sense that I got negative here. Well, let's say I wanted to find the b part is the tangent line, or the slope of the tangent line, at x equals 2. Alright, in order to do it, I'm going to do the whole limit formula. The limit as h approaches 0 of f of x plus h. So f of x is 4 over x. F of x plus h is 4 over x plus h. So I'm going to do 4 over x plus h minus f of x all over h. And what that's going to give me is f prime of x, which is a formula for the derivative. Now, I'm not going to spend time working it out because I think you can do that. You should get 4 over negative 4 over x squared. If you want to check that and make sure you understand, that would be okay. That's called the formula for the derivative, or f prime of x. So to actually figure out the slope at x equals 2, well, I'm going to plug a 2 in for x. So I get negative 4 over 4, which is negative 1. So that's the slope of the tangent line at 2. Again, it makes sense because 2 is over here between those. It's still a negative slope there, and I got a negative, so that's great. Lastly, let's say that I wanted to find the actual equation. Alright, and we want to do it at that same place that we just found the slope, so at x equals 2. So there's 3 things you need when you do a tangent line. There's x, there's m, and there's y. And we already found m, it was negative 1, that was the slope. We knew x, which is 2. To get y, that's where we have f of x, and we plug x into that. So that would be 4 over 2, which is 2. So the x and y value are both 2. Then we do y equals mx plus b. Y equals mx plus b. And then solve for b, so add 2 on both sides. So our equation is y equals, fill in your m and fill in your b. You don't have to write the negative 1. I'm writing it just so that you know where it came from. Alright, so here's your try problem. I gave you an f of x formula. I want you to find the slope of the secant line between x equals 2 and 6, slope of the tangent line at x equals 3, and the equation of the tangent line at x equals 3.